So looking at expanding and then evaluating logs, for this example, we're given that log base a is equal to 2 and log base a y is equal to 3. It's important to note that the entire log is equal to 2 or 3, not just x or y. We want to use the log laws to expand and then evaluate. Let's take a look at B and kind of see what we mean by this. So to expand, basically anything inside that log that's being multiplied can be separated into separate logs that are being added. And for division, it's just anything being subtracted. So we could take log base a y over x and split it into 3 logs that are being added or subtracted. So we'll have log base a of a plus log base a of y, and then minus for the division log base a of x. Now 2 of those we already have exact values for. We know that one of them is going to be equal to 3, one of them is going to be equal to 2. We're not given an exact value for log base a, but we know if we're raising a to some power and it's equal to a, that power is 1. So our first log is actually equal to 1. The next one is given to us as equal to 3. And the last one, which we're subtracting, is given to us as equal to 2. So we have 1 plus 3 minus 2 equals 2. And that actually works out really nicely for this one. We can do something similar for a and c. I'll leave those ones, but just to look at a to kind of set it up, we have x squared times y, so we could do a similar thing of breaking it into 2 logs. Log base a x squared, and that 2 can also become a coefficient in your next step if you want to, plus log base a y. Okay, and pretty similar steps to evaluate. It's not a very long problem once you know how to expand it out. Let's take a look at number 6 as well. Here we go. So again, it doesn't say to expand, but it will help us if we do expand. For this one, we've got log base 3x equals 10, and we want to try and evaluate this without a calculator. Let's go ahead and expand. Again, I'm going to look at B for this one. So log base 3, 27, minus log base 3x. Okay, we know that log base 3x is equal to 10, so that one will be an easy one to substitute in. For log base 327, we want 3 to some power is equal to 27. It might be straightforward that you can just say, well, you know your exponent is 3. If you're not sure, it might help to rewrite it and just write that 27 with a base of 3. It's 3 cubed minus log base 3x. We'll substitute in the next step. So we know that our first term is equal to 3, because 3 to the power of 3 gives us 27. And we know that log base 3x is equal to 10, so we have 3 minus 10, which is equal to negative 7. You can do something similar for part A and part C, just separate it into the different logs. Either calculate if it's something with a base of 3, or if it's log base 3x, then you can replace it with a 10.